We have another example on the board. The very first thing which I would do, I would redraw the circuit. Okay, so we have power supply, right? We have 9 volts. So I have power supply and I have resistor R1, I have resistor R2, and I have diode. Okay, so this is my voltage source, which is 9 volts. R1 is equal 1.6 K, R2 is equal 5.2 K, and this is my output terminal, V out. Don't forget that we measure the output voltage between output terminal and ground. Okay, so we can extend this line a little bit just to make clear that we are going to measure output voltage between V out and ground. Okay, so also keep in mind that this is silicon diode. What we're supposed to find? We're supposed to find output voltage, we're supposed to find the current, and we're supposed to find the powers. What I would do first, I would check if the diode is forward biased. Okay, so we have to first realize that the voltage source is going to push the current from positive terminal to negative. Okay, so this is my I total. Don't forget that we are using the conventional current flow. So if the direction of my total current is the same like the arrowhead of the diode, it means that the diode is forward biased. Also, don't forget that the voltage source must be greater than 0.7 volt. Okay, so I have 9 volts, current is matching, the direction of current is matching the direction showed by the diode, so means the diode is forward biased. We can write the KVL equation for this circuit. I'm going to start most of the time from ground. Okay, I'm going to start writing the equation from this point up. Okay, so I have negative voltage source, okay, because I'm going this way. Also, don't forget that anytime current is entering component, you're supposed to label it by positive sign. Anytime it's leaving, negative, positive, negative, positive, negative. So, one more time, I have negative voltage source. After that, I have positive voltage across resistor R1. Don't forget that voltage we calculate using Ohm's law. So I can say that VR1 is equal I total times R1. If comes to R2, I'm going to have VR2 is equal I total times R2. Okay, so if you want to write KVL, instead of VR1, I'm going to write I total times R1, and instead of VR2, I'm going to write I total times R2. So I have, one more time, positive sign, that's why plus I total times R1. So this is voltage across resistor R1. Next, plus, okay, voltage across resistor R2, which is equal I total times R2. Plus voltage across the silicon diode. Everything must be equal 0 volts. Next, we're supposed to solve this equation for I total. So, I have I total R1 plus I total R2 is equal, you have to move negative voltage source to the right side of the equal sign, so I have Vs, and I have to also move Vd to the right side of the equal sign, minus Vd. If you don't understand what I'm doing, especially at this moment, you're supposed to review algebra. So, Next, we're supposed to factorize I total. So I have I total, and inside of the parentheses I have R1 plus R2, which is equal voltage source minus voltage across the diode. Next, I'm supposed to divide both sides of my equation by the content of the parentheses in order to find I total. That's why I'm going to divide this by R1 plus R2, and I have R1 plus R2. Parentheses are going to cancel out, and I have I total is equal voltage source minus voltage across the diode over R1 plus R2. Okay, I'm going to add the parentheses, just make sure that you are going to enter all values correctly into the calculator. So I have voltage source is equal 9 volts. So I have 9 volts minus VD, okay, which is also called transition voltage, right? Minus 0.7 for silicon diode, divided by R1, which is equal 1.6 kilo ohms, plus R2, which is equal 5.2 kilo ohms. Okay? This is equal 1.22 milliamps. Okay? So this is the total current in my circuit. Don't forget that this is nothing else, just the series circuit, okay? Please realize that resistors are connected in series with diode and connected also in series with the voltage source. So I can say that I total is equal to current which goes through resistor R1. This is also equal to current which goes through resistor R2. And this is also equal to the current which goes through the diode. And everything, of course, is equal 1.22 milliamps. Okay, so this is my current in the circuit. Next, we're supposed to find output voltage. As we said, output voltage is the voltage between output terminal and ground. Please notice that between these two terminals we have resistor and diode. Again, we are going to use Kirchhoff voltage law, and I'm going to start my equation from this point, and I'm going to end up at ground. So let's write. We have Vout is equal voltage across the resistor. We found that VR2 is equal I total times R2. So I have positive, okay, I have to look at the signs. I have positive I total times R2 plus voltage across the diode, which is equal I total, which is equal 1.22 milliamps, times R2, which is equal 5.2 kilo ohms, plus 0.7 volts. Everything is equal 7.04 volts, okay? So this is voltage at the output. Please realize that this is one way to get output voltage. You can get also output voltage by writing the equation going this way, okay? So let's try. There's another way to find the output voltage. This is OR. Vout is equal, I have negative sign, so I have negative I total times R1, so this is the voltage across resistor R1, plus voltage source, is equal negative I total 1.22 milliamps times R1, which is equal 1.6 kilo, plus voltage source, which is equal 9 volts. Answer is equal 7.04 volts. Please notice that these two values are the same. So it means that no matter in which direction you are going to go, if you are going to go with your calculations clockwise or counterclockwise, your results must be equal or very close to each other. So from that two values, you are going to know that you are doing your work correctly. If you want to find the power at the resistor, you're supposed to simply write P R1 is equal I total raised to the second power times resistance R1. So this is regular formula for power. So if I total we found is equal 1.22 milliamps raised to the second power times R1 1.6 kilohms. This is equal 2.38 milliwatts. So this is the power at the resistor R1. Next we are going to find the maximum forward power dissipation. In other words, the power at the diode. So I have PD. Sometimes this is also written PD max is equal ID times VD is equal the current which goes through the diode 1.22 milliamps. Okay, don't forget that current which goes through the diode is equal to the total current times the voltage across the silicon diode. Okay, so this is in this case 0.7 volts. So my PD is equal 854 microwatts. Okay, this is called maximum forward power dissipation at my diode. So as you can see, we solved everything, whatever the problem was asking us to solve. We can say that problem is finished.